They called it the Abyss Files, not because someone found a treasure map, but because the ocean finally began to pry open a drawer of secrets that had been locked for millennia. In 2025, a cascade of declassified reports, expedition logs, and high-definition images turned what had been a whisper among oceanographers into a roar the public could not ignore. New species catalogued, ancient wrecks imaged with uncanny clarity, and mapping data that revealed how little of the planet's seafloor we actually understand. The headlines felt cinematic, but the truth was both humbling and urgent. The abyss is not empty, and what we learn there will change everything from conservation to commerce, science to national security. Start with the simplest shock: we still know almost nothing. A landmark analysis released this year reminded the world that visual observations of the deep seafloor amount to a fraction so tiny it's almost a joke. Roughly 1,000% of the deep seafloor has ever been seen with human eyes or cameras. That statistic isn't an academic stunt. It's a flashing red sign that the bedrock of our planet, the black plains and chimneys and canyons below 2,000 meters of water, is for the most part a dark room we've never entered. The Abyss Files made that math feel immediate. Maps that used to be blank are now being filled in with ridges, volcanic cones, and strange topography that demand explanation. And with better maps came better eyes. 2025 saw a spate of expeditions. Government, academic, and private push camera rigs and remotely operated vehicles deeper and farther than many imagined possible. NOAA's Ocean Exploration Program, long a quiet workhorse of scientific surveys, ran a series of ROV mapping shakedowns and telepresence missions, proving that when you put robust bandwidth, modern ROVs, and open streaming together, the ocean becomes a stage viewers anywhere can watch. Those expeditions didn't just collect pretty footage. They produced high-resolution bathymetry and imagery that let scientists finally tie species and habitats to exact coordinates instead of vague boxes on an old chart. That operational leap is the foundation of the files we're reading now. From those new eyes came new life. The Ocean Census Program and a suite of partner teams catalogued hundreds, and in some announcements, thousands of previously undocumented deep-sea species in recent years. New genomes, new descriptions, odd morphologies that read like alien poetry, gelatinous predators that bloom at depth, squat, armored animals that cluster on manganese crusts, tiny mollusks that thrive where no sunlight reaches. These discoveries are not curios. They are data points in the planet's carbon and nutrient cycles. Clues to evolutionary pathways and, potentially, repositories of biochemistry, biology has never sampled. The files released in 2025 consolidated decades of sporadic finds into an accelerating pattern. Biodiversity in the deep is both richer and more fragile than our models had assumed. Archaeology beneath the waves grabbed attention too. In an image that went viral across scientific feeds, a joint team rendered the wreck of a World War I submarine in extraordinary detail, the hull bones captured like a fossilized whisper on the seafloor. These wreck finds are not mere curiosities for divers. They are time capsules, sanctuaries for species, chemical hotspots, and sometimes legally protected heritage sites. The declassification of naval-adjacent survey footage allowed researchers to publish images of sites previously behind military or proprietary screens, and with that data came new pressure to balance historical preservation against increased interest, sometimes commercial, sometimes ecological, in the very places where the past now rests. But this was not only a story of discovery. The Abyss Files also read like a dossier on risk. The same mapping and sampling that helps biologists also illuminates mineral riches. Nodules of cobalt, manganese crusts, and rare earth elements that the modern economy craves for batteries, electronics, and renewables. And where the map brightens, commerce follows. Governments and private companies began to line up prospecting claims, and the International Seabed Authority's corridors hummed with new urgency. Scientists warned that we still lack baseline data on how seabed mining would ripple through pelagic food webs and carbon sequestration. The 2025 reports made that risk more visible. You can't have a rational debate about mining unless you know what you'd be destroying, and the files suddenly provided both the inventory and the warning labels. The technology thread running through all of it is vital and fascinating. 2025 felt like the year the ocean's toolkit evolved from brute force to finesse. Autonomous surface vessels and uncrewed seafloor gliders mapped more terrain with less fuel. Enhanced multi-beam sonars stitched bathymetry with unprecedented resolution. Environmental DNA, eDNA, matured from lab novelty to operational survey tool, letting researchers detect species presence from a single scoop of water. Public-public partnerships accelerated that change. Firms that specialize in geophysical surveys began agreeing multi-year deals with exploration agencies to develop persistent mapping networks, and that investment showed up in the quality and volume of data in the Abyss files. Those technological advances make the ocean more knowable, and therefore more governable if society decides to use the data that way. Security and geopolitics threaded through the pages as well. Better mapping and sensing mean better situational awareness in the maritime domain. Navies and coast guards use these same tools for anti-submarine measures, domain awareness, and port security. That's a double-edged sword. Transparency and science have immense public benefit, but the instruments that expose a coral canyon also expose a strategic choke point. Declassified datasets released in 2025 prompted quick briefings in defense communities who realized the same maps would affect everything from submarine transit corridors to undersea cable vulnerability. In short, the Abyss is a strategic theater as much as it is a scientific one. And then there's pollution, a recurring ugly refrain. The Abyss files assembled sobering evidence that deep places are sinks for microplastics, persistent chemicals, and metal contamination. Microplastic fragments were found in sediments and in animals from hadal trenches to abyssal plains. A reminder that our throwaway culture reaches the deepest reaches of Earth. The files undercut any notion that distance from land equals safety. The chemicals and particles we produce travel, settle, and enter food chains at depths we are only beginning to quantify. That's a policy problem writ large. Cleaning the ocean is not just coastal cleanup, it's systemic change in production, waste, and global stewardship. What made 2025 different from prior years wasn't just the images or the species lists, it was the democratization of access. Telepresence ROV dives stream to classrooms and living rooms. Collaborative data platforms let scientists worldwide interrogate the same raw files. And an expanding web of open access bathymetry created a shared foundation for research. The Decadal Survey for Ocean Sciences, the community's roadmap for the next 10 years, framed those needs and urged investments in persistent observation systems, integrated data networks, and workforce development for the ocean-facing careers that will be essential. The Abyss files read like a clarion call: invest, or we'll keep guessing at the rules that govern this planet's largest biome. That said, the files also exposed practical headaches. Taxonomies lag behind discoveries. Many newly observed creatures sit in museum drawers awaiting formal description. Legal regimes trail technology. National jurisdictions and international bodies wrestle with who owns seabed data, who profits from genetic resources, and how to regulate mining without stifling research. And the data itself, huge, heterogeneous, often collected under different standards, poses a major integration challenge. In short, knowledge is arriving faster than governance can respond. The Abyss files record not just nature's secrets, but humanity's scramble to decide what to do with them. So what comes next? Expect a multi-fronted race. Scientists will push to turn eDNA, autonomous platforms, and improved sonars into routine, repeatable monitoring so we have baselines, not one-off curiosities. Policymakers will be forced to choose between moratoria, precautionary frameworks, and fast-tracked exploitation. Industry, sensing both opportunity and risk, will pour money into licensing deals and in-house exploration, and the public conversation, now fueled by immersive footage and dramatic discoveries, will be harder to ignore. Citizens will demand that oceans, which regulate climate, feed billions, and house untold life, be managed with evidence and care. The Abyss Files are not an endpoint. They are the beginning of a modern ocean story. They tell us that fascination is no excuse for delay. They make it clear, if we want to reap the scientific, economic, and climate benefits the deep ocean offers, we must invest in durable observation systems, robust legal frameworks, and equitable models that put creators, coastal communities, and small nations at the table. Otherwise, the same technology that revealed the abyss will also be the tool that strips it bare. The declassified discoveries of 2025 offer both a mirror and a warning. We can study, protect, and learn from the deep, or we can let it become another resource frontier, where the costs are borne by ecosystems we barely understand. If you felt the chill reading the Abyss Files, that's by design. The deep is beautiful and strange and fragile. This year's releases lifted the veil slightly, but they also showed us just how much more remains to be revealed. The question now is not whether we can explore the abyss. We can, but whether we will do so wisely. If this unpacking helped you see the stakes, share it. The ocean belongs to us all, and the choices we make in the next decade will define its health for centuries.